One of the geometric applications of dot products is that I can use a dot product to find the angle between two different vectors. So if I had a vector like 2, -1, and call that u, and -3, 4. So if I were to graph that, go over 2, down 1, so that's one vector. And then over 3 and up 4, that's another vector. Now, the angle that I'm going to get is always going to be between 0 and 180 degrees. So if I found the dot product, so u dot v is going to be 2 times -3 plus -1 times 4. And I'm going to divide that by the magnitude of u, which was what? The square root of 2 squared plus -1 squared times -3 squared plus 4 squared. So when I simplify that, and this is all what cosine of theta is going to be equal to, I'd have -6 plus -4, -10, all over the square root. I'm going to put it in one big thing. 4 plus 1 is 5. And here I'd get 9 plus 16 or 25. Which, yes, we could simplify that by taking a 5 out here and canceling with that. So basically, I'd be getting -2 over the square root of 5 is equal to that cosine of the angle. So in my calculator then, I can say, take the inverse cosine. And inverse cosine, I'm allowed to have negative values. In fact, it tells me it's going to be an obtuse angle. And when I go ahead and do that, or if I put -10 over 125, either way, the angle that I end up getting is equal to 153.4349 degrees. Now, it's really hard to tell in this picture because it's not very exact, but it certainly appears that it's a obtuse angle, and that's how it's 153 degrees, and so I feel pretty confident that that's the right way. I don't think I made any mistakes. Now, one of the things that we'll find here is that there are times that when you do inverse cosine, you'll have something where you're going to be you'll be saying cosine of theta is equal to 0. It's possible that the dot product of two vectors is equal to 0. And you should remember from the last chapters that cosine is equal to 0 when theta is equal to 90 degrees. Okay? If the dot product of two vectors is 0, you get what are called orthogonal vectors, which for the most part that's going to mean that they're perpendicular. There's one exception, okay? So it's almost always perpendicular. The one exception is all vectors are orthogonal to a 0 vector. A 0 vector has no direction, no magnitude, okay? It would be like this. And so it's kind of hard to say how can you be perpendicular to nothing, so we have this term orthogonal. For the most part, if I have two vectors that have magnitude and they end up being orthogonal, or their dot product is 0, then I'm always going to have the dot product will equal 0 because they're perpendicular. So that's the angle between vectors and being orthogonal.